In this video, we'll do another example of a related rates problem. So let's say that the equation 2x squared plus 5xp plus 50p squared plus, equals 80,000 relates the demand for a certain widget, whatever that might be, um, in correlation with the price for that widget. So let's say that p is the price in US dollars. And let's say that X is the quantity demanded. Let's say, I don't think this needs to be in thousands. I think we'll just go with quantity demanded. Um, let's say this is like per month. Right? On a monthly basis, this is how many are demanded. So when the price is 30, so $30, if the price is changing on a month-to-month basis, maybe this is a commodity, not a widget, right? Maybe this is, oil or electricity or water or something like that. Let's say that this is going up $2 per month. Okay, so the price is 30, but on a month-to-month basis, it's going up by 2 every month. So $32, $34, $36, as an example. So the question is, how is the demand changing? Oops. Okay. Now, of course, if the price goes up, you would expect demand to go down. Well, okay, sure, but how much? It goes down by how much? So I'm going to need to apply the time derivative to this equation. So dt of 2x squared plus 5xp plus 50p squared equals d dt of 80,000. Okay, so the right hand side is easy. The derivative of a number is just 0. The left side, however, has 3 terms, so we have to be careful to handle them each correctly. The first term is just the power rule, chain rule, nothing too difficult. And the last term, same thing, power rule, chain rule, nothing too difficult. It's like the ones we've done in previous videos. The middle term, however, is a little bit harder because if you don't pay attention, you might overlook this. We have to use the product rule here. We have a product of 2 functions of time. The demand x changes as a function of time, and the price p changes as a function of time. So I'm going to have to use the product rule. So I'll go ahead and find the derivative here. This one, this is 4x dx dt. And the next term I'll put in parentheses. I don't need them, but well, you know what? Let's put the 5 outside parentheses. 5 times the derivative of x times p. And again, I have to use the product rule. So remember that the derivative of uv is u prime v plus uv prime. So in other words, the derivative of the first factor times the second factor plus the first factor times the derivative of the second factor. So I'm going to write this out like this. d dt of x times p plus x times d dt of p. So that's the second term. Okay. I'm running out of room here, so I'm going to move this over a bit. Yeah, that should be okay. Plus, I have to change, go back to this term, not change, sorry, about to say change back to something, but no. I need to apply the power rule to this guy. So 100p times dp dt. And this all equals 0, because of course the derivative of 80,000 is 0. So I still have to work with these guys. It's difficult, I just wanted to do it in 2 steps. So the derivative with respect to time of x is dx dt. Again, we don't have, as before, we don't have x as a function of time, we just know that it changes as a function of time. And then d dt of p is dp dt. Okay, so I'm going to have 4x times dx dt plus 5 times dx dt times p plus 5 times x times dp dt plus 100p times dp dt. Okay. So the calculus part is basically done. Well, yeah, basically the calculus part is done. We're going to have to keep calculus concepts in mind, but we're done finding derivatives. So what I need to do is I need to plug in numbers for x, dx dt, p, dp dt, all of these, well, except for one, right? I'm asked to find how is demand changing. That's dx dt. So I'm not given dx dt. So it's actually only x, p, and dp dt that I'm plugging in. Dx dt is what I'm solving for. So I'll make a note of that up here, which we could have if we'd wanted to do it up here. Dx dt equals question mark. That is what we're looking for. Okay? Now, I don't have a number for x. I wasn't given a number for x, right? I was given a number for p, and I was given a number for dp dt, but I was not given an x value. So we have to find an x value. So go ahead and pause the video and think for a minute. How are we going to do that? Okay, so to find x, what I have to do is go back to the original equation. I have to plug in 30 for p and then solve for x to get a number for x. Okay? So I'm going to use a different color so it stands out and this doesn't run together. So 2x squared plus 5xp. Now p is 30, right? So 150x after I plug in 30. Plus 50 times p squared. P squared is 900 times 50 is 45,000. So our numbers are getting kind of large, but it's going to be okay. Equals 80,000, right? Yeah, 80,000. Okay, so I'm going to not divide, sorry. I mean, I could divide, but I'll start by subtracting 80,000 on both sides. So 2x squared plus 150x minus 35,000. And the numbers are large, but don't worry. Now, since everything is even, all those coefficients are even, I'm going to divide by 2 on both sides. So x squared plus 75x minus, what is that? 17.5. Okay? Now, it probably is not obvious at all how this factors, but it does factor in a relatively easy way. You might notice this 75 here. That's your clue basically. So I think I did this right. Hopefully it's correct. So this factors as x plus 175 times x minus 100. And I'm skipping the detail there. If you would like to see more detail on how to do that, just put in the comments. I can probably just explain in a comment. That probably shouldn't be too hard. But basically, I'm using the AC method. I actually have the solution off to the side here, but 175 minus 100 is 75, right? And 175 times negative 100 is negative 17.5. So, yeah, that's basically how that works. When in doubt, you can use a quadratic formula to solve a quadratic equation. You don't have to do this via factoring. So, I have my two factors. So either this first factor equals 0, or this second factor equals 0. So either x is negative 175 or x is 100. Okay. Now, since x represents demand for some product or commodity, you can't have a negative demand. That just doesn't make any sense, right? So x equals 100. So what I can do now is take that equation, copy it down here. So 4x, I'm going to run out of space, that's okay. 4x dx dt. This is a little more involved than previous examples. Dx dt plus 5 dx dt times p plus 5x dp dt plus 100p dp dt equals 0. I think that is everything correct. Okay, so now I can plug in numbers. 100 for x, I can plug in 2 for dp dt, and 30 for p. So 100 for x. So 400 times dx dt, which again, that's the thing we're looking for. That's why we don't have a number for it. Plus 5 times 30, so 150. And I think I have a mistake here. I put a plus twice. Yeah, I just put plus twice. Okay. Plus 150 dx dt. Again, the 150 is from the 5 times p, which is 30. Okay, so now plus 500 times 2 plus 3,000 times 2 equals 0. Okay, I think that's all done correctly. So I'm going to have 550 dx dt plus, well, this is 6,000 and this is 1,000, so 7,000. So I can subtract 7,000 on both sides. So I'll have dx dt, or rather, sorry, 5,000, or 5,500, sorry, 550 times dx dt equals negative 7,000. And then divide the 550 on both sides. Now I can do a little bit of reducing, these zeros reduce, right? And then the top and bottom are both divisible by 5. So dx dt equals negative 140 over 11. And that is approximately negative 140 divided by 11, 12.72. What was the scale of these numbers? This quantity. Okay, we'll go with 12.72. That's fine. Or 73 rather, rounds. Negative 12.73. So this means that demand will go down by about 13 units. About, well, I'll say 13 units, whatever those are. Of course, if this is like some commodity that you can buy in fractional amounts, well, then we went around to 13. But we don't know the context, so we'll just go with that. So this problem was a little bit more involved than the other ones, because the last few examples, because we were given sufficient information. We were able to solve the problem, but we weren't given what x is up front. We had to work that out, which took a little bit more effort. So you got that. That's an example of a related rates problem.